everybody, it's Miss K. I hope you guys had a wonderful weekend. Today we are going to be introducing something called slope. I say, you say, slope. Slope. The slope of a line measures the steepness of a line. Steepness, for example, let's see, if we had like a slide that you go down like this versus a slide like this slide is steeper. It's more steeper than this one, because you would go down it faster. Same for lines that go up. This line would be harder to climb because it's more steep than a line like this. This one is more steep, which is another way of saying steeper. Tomorrow, Miss Holland is going to talk about slope and steepness, except she's going to talk about it as the rate of change, because the slope of the line also shows us what the rate of change is, how much something is happening each time over a period of time, or a period of whatever you're measuring. There are three main types of slope that we're going to start with. There's actually four, but you'll learn about the next form later in this unit. So let's look at our first graph. I'm just going to draw a line. So if we look at this graph going from left to right, you can see that we are increasing. We would call this graph is increasing. When a line is increasing like this, we call this positive slope. Because if we found our rate of change, our slope would be positive. Just gonna move this over a bit to give a little more space. So, kind of the opposite to that, if we had a line that's going down like this, well, this line is decreasing. Like you're going down a hill. Increasing, you're going up a hill. Decreasing, you're going back down. This graph is decreasing. And we call a graph that is decreasing, like a line that's decreasing, we call this negative slope. Your numbers are going down. The last type of line we're going to study for now is one that goes straight across horizontally. So notice this graph is horizontal, meaning it's like a flat line across. We could just say this graph is constant. That just means this graph isn't going up, it's not going down, it's staying constant in the same spot each time. We call this zero slope. So we have three different types of slope: increasing, decreasing, and horizontal. We call this positive slope, This is negative slope. This is zero slope. So then our question is, how do we find the slope from a graph? So we have two examples here. Let's look at this one first. This line is increasing. So we could say, I'm going to change this to the graph. The graph is increasing. So we call this positive slope. Over here, we have a graph that is decreasing. And we call this negative slope. So now I'm going to show you how to find your slope. Last week in our lesson, Miss Holland drew what we are going to call in this lesson slope triangles. To measure the steepness of a line, we need to see how much it's increasing going up compared to how much it's increasing on the bottom. We're always going to draw our slope triangle from one point on your line to another nice point on your line, and it's always going to go underneath the line. So I could draw a different one over here if I wanted to, from 2 points. The next step is to figure out the distance of each of these points. So let's see. Let's look at this part first. We want to know how long that part is. We call this how much does our graph rise. Let's look at the scale over here. We go 0, 2, 4. That means we're going up by 1, 2, 3, 4, 5, 6, 7. So we go from a height of 3 up 1, 2 to a height of 5. This rise is 2. 1, 2. What about over here? We call this distance our run. On the bottom here, we go 0, 6, 12, 18, 24. Well, halfway between 0 and 6 is 3. So we're going up by 3s. This point starts at 18 and ends at 30. So we could either count by 3s, 3, 6, 9, 12, or we could do 30 minus 18 is 12. Okay, so we have how much we are increasing this way for how much we are increasing this way. To write our slope, we're going to write it as a fraction. It's kind of like a ratio between the rise and the run. How much our graph rises for how much we're running. Well, we rise 2 over a run of our slope is 2/12. But if you remember from last year, this fraction is not completely simplified. We can divide the top and bottom by the same number, 2. So let's see, I get 2 divided by 2 is 1. 12 divided by 2 is 6. Our slope is 1/6. I want you to notice we found the slope using this triangle. We also could have used this triangle. The rise here is just 1 block, and the run from 6 to 12 is 6. 1/6. That would have given us the same slope. Because our graph is increasing and we know the slope is positive, we're glad that we got a positive number as our slope. Let's look at one that's negative. So I'm going to start. They actually gave us 2 points, which is nice. I'm going to draw my triangle. Remember, our triangle goes between 2 points, and I'm going to draw our triangle underneath the line. Okay, so our slope, if we remember, is our rise over our run. So here's where we have to be careful. When I go from this point to this point, am I increasing or am I going down? Notice over here, when I went from here to here, I was going up. When I go from this point to this point, I'm going down 2. So my rise is -2. And my run, because I'm going by ones, is 1, 2, 3, 4. So my slope is down 2, so -2/4. Notice I can divide the top and bottom by 2. So I get a slope of -1/2. Here's why the slope is nice. It can tell you what to do on your graph. I'm going to pick a nice color to use. Let's use this color. It says -2 or -1 on the top. That means starting at whatever point is on my graph, I can go down 1, because it's negative, over 2. Whoops. There we go. Down 1/2. Down 1/2. So I can go down 1/2, down 1/2, down 1/2, and I can graph my straight line using the slope. All right, you guys have just 4 problems to do. You need to find the slope for each one and decide if the graph is increasing or decreasing, and if the slope is positive or negative. Remember, if it's decreasing, our slope will be negative. If it's increasing, our slope will be positive. I hope this video helps, and I hope you guys have a wonderful day. Bye!